Good day to all. I am Dr. B. Yamini, Department of Computer Science and Engineering. In this video, we are going to see about part 3 video for the 3D transformation. In part 1 video, we have seen about the introduction to 3D transformation and 3D translation. And in part 2 video, we have seen about 3D rotation. In this part 3 video, we are going to see about 3D scaling, 3D reflection and 3D shearing. Let us go into the topic. What is scaling? Resizing the object. Either you go for increasing the size of the object or decreasing the size of the object. That is going to be done. So this is what called as scaling. So when you go for increasing the size or the decreasing size of the object, what will happen? The positions of the object will also get changed. That is, there will be change in position of the object when we increase or decrease the size of the object. So obviously your x, y and z coordinates will also get changed. So performing some scaling operations on the old objects with the coordinates x, y and z will give you a new position value, say x dash, y dash and z dash. So this is what 3D homogeneous coordinate representation, 3D point homogeneous coordinate representation of the 3D scaling. X dash, y dash, z dash are the new coordinates that are obtained after scaling operation. That is, scaling operation here is represented as scaling on x-axis, scaling on y-axis, scaling on z-axis. On the original coordinate value, say x, y and z of an object. So what happens? A new value will be obtained, say x dash, y dash and z dash. The equation is represented as x dash is equal to x dot sx. That is performing scaling on the x-axis on the original old position of the object along the x-axis. So you will be getting new x dash. Similarly for y dash and z dash. And now 3D reflection. What is reflection? If I stand before a mirror, my image get reflected onto the mirror. What happens? But my right hand side will be represented as what? Left hand side in the mirror. My left hand side will be represented as right hand side in the mirror. Why? Because it is of about 180 degree rotation. If it is of 360 degree rotation, what will happen? The mirror will represent my right hand side as right hand side itself and my left hand side as left hand side itself. This is what the reflection is. Here in the reflection in computer graphics is used to emulate reflective objects like mirror and shining surfaces. There are number of types of reflections: x-axis, y-axis and z-axis reflection. Even the plane reflection is also done. That is xy plane reflection, yz plane reflection and zx plane reflection. So the reflection relative to a given axis are equivalent to what? 180 degree rotation. See, for example, here it is the x-axis rotation which gets 180 degree rotation, so that what happens? 180 degree reflection is done over here. This is for y-axis. So what happens? The object in this case will be rotated 180 degree. That is reflected not rotated, it is reflected 180 degree. Similarly for z-axis, here the object is getting reflected by 180 degree. So this is what the reflection here. And for x-axis reflection, 3D reflection can be given as x-axis is get constant for x-axis reflection, whereas there will be a change in y and z. Similarly for y-axis, y will kept as constant, but there will be a change in x and z. Similarly for z-axis, z will be kept as constant, the same. You will be getting the same value, but there will be a change in x and y. So for x-axis, x is same, y and z are minus 1, minus 1. X is same. For x-axis, x is same and y and z are minus 1, minus 1. Similarly for y-axis, y is the same value, but x and z gets minus 1, minus 1. X and z gets minus 1, minus 1, but y remains the same. Similarly for z remains 1. Z remains 1, but x and y gets minus 1, minus 1. X and y gets what? Minus 1, minus 1. The next one is 3D shearing. What is 3D shearing? Modifying the object shape. This is useful for perspective projections. What is perspective projection? You will be viewing an object from different directions, from different distance. What will happen during that time? The appearance of the object will also get changed based on the distance, based on the angle of view. The object representation will also be changed. So the perspective projection mimic human eyes. So this is what the example for shearing. So what happens here? This is the object represented here. I am going to shear it to this position. What happens here? Z is kept as constant, but there will be a change in what? X-axis and Y-axis. Z is kept as constant. The object is moved backwards to the origin. z-axis is kept constant, but there is a, since the object size is modified, so what happens? X value gets modified and y value gets modified. So that is why it has been represented as AB. AB can be assigned any real value. That's it about 3D transformations. Thank you.